Hello, it's Friday the 9th of October, and this is episode 28 of the Unseen Podcast. Regular host Paul Carr is taking a well-earned break this week, so he's kindly handed over the reins to me. I'm your host this evening, Adam Smith, although I sometimes adopt rather dubious pseudonyms so people can find me among the several hundred other Adam Smiths on the internet. This evening I'm joined by two of our regular panelists. We have Patrick Festa and Nick Nielsen. And tonight we're going to be talking about solar system exploration. This week happens to be World Space Week, which was an event instituted by the United Nations back in 1999 to celebrate and promote human activities in space. The United Nations chose the first week in October because it marks the anniversary of the launch of the very first man-made satellite, Sputnik, which was, of course, launched on, I think it was October the 9th, by the former Soviet Union. And since then, many hundreds of satellites, space exploration vehicles, and manned spacecraft have gone into space. So, let's begin. Rather than try and discuss the entire 58-year history of spaceflight, let's look at where we are today. We have, starting at the center of the solar system, the Sun. We have solar observing spacecraft. I can think of 4 off the top of my head. There's SOHO, which has a wide field view of the Sun, looks at coronal mass ejections and sun-grazing comets. There's NASA's Solar Dynamic Observatory, and the 2 stereo crafts, Stereo Ahead, which orbits ahead of the Earth, Stereo Behind, orbits behind the Earth, both pointing at the Sun. And then, moving outwards, there's nothing currently at Mercury, although there was the Mercury spacecraft, Messenger, NASA's Messenger, stopped operating last year. It was deliberately crashed into Mercury after a fairly successful science campaign. And then, of course, there's Venus. There's nothing currently at Venus. The European Venus Express was orbiting Venus. But I heard just recently that there are 2 interesting mission proposals for the NASA Discovery class missions to Venus. You guys know about them? Nick, do you know anything about the proposed missions to Venus?
Nothing in detail. I know that NASA recently made major announcements of 5 candidate missions that were being seriously considered, and a couple of them were Venus missions. But I have not taken the time to read about them in detail.
That's right. I think one is. Sorry, Pat.
No, I was just going to say I only heard there was some YouTube documentary video I was watching about them discussing the possibilities of getting something up there, because what they need to do is get something up there that lasts longer than an hour. Yeah,
I think the idea is that one of the proposals is for an orbiter, which will orbit for a few years. The other one is quite an interesting proposal about dropping something into the atmosphere, and it will gradually descend over about an hour and take measurements of the atmosphere, pressure, temperature, and image the surface of Venus as it slowly descends on a parachute or some sort of balloon, I would imagine. But that's good. I like the idea of sending something to Venus, because I think it doesn't get the love it deserves, Venus. A lot of people talk about Mars. There's a lot of talk at the moment about Mars. Sending people to Mars.
Well, Venus has been...
There are the rovers.
Venus has been largely left alone, so to speak, because of the difficulty in getting something there to actually last long enough. But whatever happened to that radar mapper that they sent up there? That took some detailed radar maps of Venus, didn't it?
Yeah, Magellan.
And also in the early stages of the space program, the Soviets sent a whole series of Venera missions that did make it to the surface and only lasted for a very short period of time, but they did return some photographs from the surface of Venus. So I find it quite interesting that there was this early focus, at least in the Russian space program, on Venus, and then very little since then. But as you've stated, it's a very difficult environment. Though that doesn't explain the absence of more orbiters, and especially one would want to see orbiters with cloud-penetrating radar or something like that. And also, Mars is just a more attractive candidate for the symbolism of it and the possibility of human beings actually settling there.
Yeah, I think it's fair to say that of all the bodies in the solar system, the terrestrial bodies, Venus is the one that's least likely to be habited by us anytime soon. We're simply not going to be able to walk on the surface of Venus.
Yes,
without some very drastic changes to its atmosphere.
Many years ago, in some speculative fiction essay, a person suggested that terraforming Venus might be done by redirecting comets to strike it around the equator to make it rotate more rapidly, and that rapid rotation combined with other changes introduced in a sea around the equator where it was hottest might make the poles habitable. But of course, that's a kind of gigantic astroengineering project that would not be possible anytime soon, as you point out.
That sounds like science fiction.
Yeah. Theoretically, that is correct. If Venus were to spin a lot quicker, it probably would be a lot more easy for us to get to the surface. It would be less hot. There'd be less pressure. That would be the way to do it. But how do you get a planet nearly the size of the Earth
to spin faster?
Why? And the other thing, of course, is just like Mars, it's the lack of magnetic field, which is why Venus is the way it is. In essentially, it's almost the same thing as Mars, only opposite. It got hotter because of the sulfides and stuff. I understand there's actually current volcanism going on, or is that?
Yeah, there are volcanoes on Venus,
which is spewing the sulfides and stuff into the air, which is why it's so hot.
There's a very large volcano, Mons Map, which is huge, but we're not sure if it's active.
Oh, see, I don't know. But there's no magnetic field to shield. I mean, even if we were to snap our fingers and magically terraform Venus, would that not still need a magnetic field to protect, especially being closer to the sun, protect us from the radiation?
Presumably it would, but if you could reach that level of technology, then generating a magnetic field around the planet would be the least of your concerns compared to being able to speed up the orbital, the rotation of a planet that size. Though it's fun to speculate why or how these things might be done with the less extreme methods. So may we infer from the lack of a magnetic field around Venus that it doesn't have a hot molten rotating core at its center?
Yeah, that's what I'm thinking. It's like how could it have volcanism if it doesn't have a hot core?
I'm not so sure that it doesn't have a magnetic field, actually, Patrick. Are you certain?
I was watching a video just earlier today, and it suggested that it lost most of its moisture the same way Mars lost its atmosphere, in the sense that the solar wind blew a lot of the water vapor away because of the lack of magnetic field. I'm not sure if that documentary was accurate. It was one of those made-for-TV kind of documentaries, but it was on YouTube.
Okay. I know that Venus does have like a tear-shaped atmosphere as a result of the solar wind. Some of its atmosphere actually trails behind the planet as it orbits.
Presumably, it's
So you
subject
well
to.
right.
Presumably, it's subject to greater solar winds than Earth, and presumably Mars is subject to even less solar wind than Earth, given its position.
Yeah.
And maybe the greater solar winds could overcome a weak magnetic field, but I haven't read up at all about Venus's magnetic field, so I really don't know anything about it.
Well, aside from the science fiction speculation, wishful thinking, still we need to know more about Venus because of the so-called sisterhood we have. The problem, of course, is the lead would be a good metal to use in the thermometer type of deal. We have to figure out how would we get something. The Russians managed to get something to last for about an hour, I think, on the surface, and it took a few snapshots, which were very cool. But nevertheless, it was amazing that it even lasted an hour. So how do we get something? What do we make this thing out of that'll take temperatures in upwards of 700 or more degrees? Not to mention the acid rain, the acidity of the atmosphere and everything. So I mean, that would be the big thing. I mean, how do we do that? How do we get something to last? And then the electronics has to be somehow shielded.
I think it's fair to say that's beyond the moment.
It's a serious engineering question, and one wonders how it could be solved.
Yeah, maybe we could take a page out of the Russians' book and see how they did what they did, even if it only lasted an hour. An hour is actually quite an achievement.
It was,
and taking pictures and being able to send those pictures back. I don't care if it was just 2 shots. To me, that's an amazing thing to be able to do in a 700 or 800 degree environment.
There was a Soviet scientist that claimed to have spotted signs of life on Venus. Have you ever read anything about that? I don't recall his name, but in some of the images returned from one of the Venera probes, he claimed to have seen a small scorpion-like creature moving around on the surface.
I haven't heard anything like that.
Let's just say I would be highly speculative on that one.
Russians sometimes make some remarkable claims on the basis of the data set that they possess.
Oh, the amount of vodka that they happen to have been drinking at the time. Yeah.
Although, I mean,
anyway,
I guess anything is possible considering the extremophiles that live in the hot vents that are in the bottom of the ocean. It's
interesting. It's hard to imagine anything living life as we know it, living on the surface of Venus. Well, you never know.
Yeah, I'm going to put that.
So
one
let's carry on moving outward.
Yeah, I'm going to put that one along with the science fiction also.
Yes. Okay. So let's skip over the Earth and move onto the Moon. The Lunar Reconnaissance Orbiter is still in operation. NASA's Lunar Reconnaissance Orbiter is still doing a fine job mapping the surface of the Moon. And the Chinese have been taking a lot of interest in the Moon recently. They have I think it's called Chang'e 3 lander on the Moon. I don't think it's still operational. I think it stopped working in the summer, around about June. And they had the U2 rover, which didn't last that long. I think it lasted for a couple of weeks. But it's very, very challenging environment, of course. It's very cold on the Moon, and things don't tend to work very well. But these are challenges that a number of teams are trying to overcome over the next couple of years with the Google Lunar X Prize. It was in the news just recently this week that the first of the Google Lunar X Prize teams has booked their trip to the Moon. They've got a contract to fly, I think it's the Israeli team. It's called Team IL. And their rover has got itself a berth on a rocket to the Moon sometime in 2017, I believe. I think the deadline that Google have put down for getting there is the end of 2017. So sometime before then, we should see some new rovers on the moon. That's interesting.
Is Google offering a prize to make this happen, or are they responding to a prize?
Oh, yeah, they're offering a prize. It's a few $1 million. I'm not sure of the exact figure, but it's a substantial amount. It's in the millions. Initially, they had a deadline of last year, but none of the teams that have entered managed to they made significant progress towards building their rovers, but none of them were able to match that deadline. So Google put it back to 2017. And I think there are around 7 or 8 teams around the world, privately funded teams, looking at driving their rovers on the moon. The prize that Google have offered is to land a rover, drive it 500 meters, and return HD images back to the Earth. If they do that, they receive a few million quid, which is a good incentive. I think most of the teams are university-led missions. They're based in a variety of universities around the world. There's a team in Hungary, a team in Israel. There are 1 or 2, maybe 3 in the United States. And they look like they're going to do it.
Do you know if they only have to? You know if they only have to design the rover, and they presumably they don't have to be responsible for the boost vehicle?
No. They can basically choose which rocket they want to send them to the moon. You know, you've got a choice between United Launch Alliance. I don't know if you'd need an Atlas V. Probably something smaller would do it. But some of the teams are looking at jointly booking a rocket trip to the moon. I think what we'll see is 2 or 3 of the different teams clubbing together to go on the same rocket, which is good because we might well end up with 2 or 3 rovers landing on the moon at the same time, and then they'll have a race across the surface of the moon. That'll be quite a spectacle.
That would.
Who's going to bring the Christmas tree lights? You know, the ding, 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 go. But seriously, what was the spacecraft slash country that discovered these caves on the moon? And we need to explore them. There was talk about exploring the caves.
The lunar lava tubes.
Yeah, there are skylights, aren't they?
I believe ground-based telescopes or maybe lunar orbiters spotted this possible skylights, the lava tubes, but I know that there's an academic paper that's been written about them. I linked to it on a blog post once, and the speculation is because of the low gravity and the geological stability of the moon that the subsurface lunar lava tubes may be quite large, measurable in kilometers, and therefore would be a good place for a moon base, as it were, or a settlement, because it would be protected from the cosmic rays by the overburden, as it were.
Yeah, I think it was the NASA's Lunar Reconnaissance Orbiter which discovered the ones at Mortis Lacus. It's either Mortis Lacus or Lacus Mortis.
Don't curse
I'm not sure which. But there's a skylight. And
I thought there was some photo or something that was sort of close up, zoomed in or something.
Yeah, I think it's Lacus Mortis.
There in the Google page for lunar lava tube, it says that an opening to such a lava tube may have been discovered by the Japanese Kaguya spacecraft.
Okay.
The Hadley Rill may have been a partly roofed lava channel, some parts of which have since collapsed. There may also be lava tubes in the Mare Serenitatis, excuse me.
Yeah, that's the place to be, isn't it? If you want to go live on the moon.
Well, they were talking about the resemblance or the possibility that, excuse me, the idea of trying to colonize Mars, for example, Mars may have extensive caves because it was obviously at one time a highly volcanic planet, and maybe they can use that as the shielding, for settlements, something to that effect. There was some discussion going on about the ideas.
I heard that as well, and I was assuming that it must be around the Olympus Mons. I read somewhere quite a while ago that the reason that Olympus Mons got so huge on Mars is because there's no plate tectonic activity. So the one place where there was a weak spot on the surface where the molten lava could come up just built up the one huge mountain in one place. So I'd assume if that is the hot spot for volcanic activity on Mars, that's where you would find the Martian lava tubes, if there are any.
And I'm going to make a leap of assumptions here, but I assume that this lava rock is probably a decent shield in some sense.
I would think it would be a decent shield. How many feet of material do you need between you to adequately protect you from cosmic rays and other form of solar radiation?
About 5 meters.
That's a lot more than I expected, but not impossible. Certainly, yeah. I would expect the roof of a lunar or Martian lava tube to be more than 5 meters, and if it was less than that, you would see the collapsed skylights that have been discussed.
Yeah, I mean, if you think about it, this Mars One is talking about these habitations and stuff, or these habitats. How are they going to shield themselves? How are they going to? What's his name was talking about the shielding he's working on, this nanotechnology. But I'm thinking Anne McCaffrey here. The Pern planet. Where they had to shield themselves from this organism that came by every couple hundred years, and they often found cave dwellings.
I never read the Dragon Riders of Pern novels, but in principle, certainly people could find a way to live in caverns, but it doesn't conform to our romantic image of Martian astronauts roaming across the red desert in light spacesuits and hopefully making a garden, although there are still ways to make that work and still ways to use lava tubes, whether on the moon or on Mars, to protect human beings and sensitive electronic gear. And the other thing I wanted to mention about lava tubes is it's not just about human settlement. Someone has suggested building a supercomputer on the moon, which I think would be a great idea because it would be the ultimate backup. That would have a high degree of survivability regardless of what happens on Earth. If you've got a lot of potential electric power from solar panels, whether on the moon or Mars, and if you put a large supercomputer in a Martian or lunar lava tube, it would be protected from radiation and presumably have fairly constant climatological conditions. And you could back up all the data on Earth remotely at a spot where it would be very safe.
Yeah, that's a good idea.
I see it as the first stage of a civilizational backup, as would the equivalent of a Svalbard seed vault on the moon or Mars, which would be the first stage of a biological backup of the biosphere off of Earth, and therefore the first stages of existential risk mitigation.
Yeah. I was looking earlier today at NASA's strategy for getting people to Mars. And they're talking about using the space around the moon as a proving ground for their technologies to get them to Mars. Developing and testing the technology that will send astronauts out into deep space. Whether that means they're going to orbit the moon, I would imagine it does. I don't think they've got any plans to actually land on the moon. using the new what is it called? The STS, is it? Space Transportation System, and the new Orion capsule. They tested it, sent it on an unmanned trip round the moon, but there are no plans to. NASA don't have any plans to revisit the moon, but the Chinese do. The Chinese are talking seriously about a mission to the lunar far side, which is interesting because no one has ever set foot on the far side of the moon. Presumably, they'd need an orbiter to maintain contact with the Earth. They'd have to relay communications to the orbiter. The orbiter would have to then relay communications back to Earth. Be a very difficult mission, but they look to be going ahead with it.
We have an orbiter up there. Could it not be used?
I don't think NASA would allow the Chinese access to their lunar reconnaissance orbiter. No, we won't let them on the International Space Station, will we?
In principle,
that's why the Chinese have their own.
You could land a person on the far side of the moon without having communications continuously. Obviously, people would view that as a pretty risky endeavor, but it doesn't. If you've got a spacecraft in orbit, there's no reason you can't use it as a relay back to Earth.
Yeah, I'm willing to bet that the next person to set foot on the moon will be Chinese.
You may well be right.
I wish them good luck.
Well, I would say there was an even odds with a private industry effort or a Chinese effort, because space exploration is full of symbolic firsts that have yet to be realized, and the first private industry that stakes its flag on the moon or on Mars or sends somebody somewhere more than as far as private industry has gone, say with the Spaceship One that won the Ansari X Prize. All these things are going to make the history books, and they're only going to happen once. And very few people remember the second person who did it, but they certainly will remember the first person, or institution, or company.
That's right. We are about to enter into a new age of private spacefaring, private companies going out into space to mine the moon, mine asteroids. There are a couple of companies seriously looking towards mining asteroids.
Really, the technology is there and the money is there. It's just a question of people wanting to spend their money on that particular technology and enough of it to make it happen. Obviously, we know how to get to the moon. We know how to get to Earth orbit. We do need robust spaceships of a renewable kind that can be counted on. There are obviously several private enterprises that are working on that, and we all know that once that low Earth orbit becomes easily accessible for a reasonable price, that's going to change a lot of what goes on, because it's still very expensive to get to orbit. It still involves chemical rockets, which are a very old technology, and there are several alternative technologies or other ways to save money that have not been exploited, just because investors are risk averse and don't want to get into something as terrifying as space exploration.
Yeah, space is hard. We know that. It's not easy, is it?
It's hard, but it's hard as an engineering problem. But in principle, it's not particularly hard. And I'm saying so. I'm echoing Paul Carr from earlier Unseen podcast, where he said, well, basically, you just have to get enough of certain materials into orbit, and you can support people. So in theory, it's not a problem, but engineering-wise, it is very difficult. But there's so much money in the contemporary world is held in private hands. Like I said, if they wanted to do something, they could do it. It's just that they either don't see the opportunity or they don't want to take the risk.
Yeah. Are you guys disappointed with the where we're at the moment in terms of space exploration? I mean, when I was a kid, I imagined we'd have orbital space stations with people living on them, people living on the moon. You know, I grew up in an era when the Apollo missions had happened, people had been to the moon, and a lot of people thought that we would be out there in the solar system by now, and it hasn't happened. Are you happy?
Yeah, I'm disappointed. I wouldn't say that I expected us to be living out there, but I certainly expected us to have more science being done. Possibly, you know, something on the moon, but I wasn't counting on it. But nevertheless, there's a you know me as a pretty hard-nosed atheist, and I've been telling people there's like a war on science, and that's part of the reasons why we've been held back by the religious, you know, side, because of it's just not, you know, people aren't interested, especially in this country, and it's really a shame. And the deniers and things like that. So yeah, I'm disappointed in that I think we've been held back. Whether or not we would have had people living out there or not is maybe, but it's not something that I counted on. On the other hand, I did expect to know more. Although I am pleased to see the studies of the sun, the stereo spacecraft, those two orbiters around the sun, I thought was an amazing thing. I thought the SDO was absolutely wonderful. I was like, wow, look at those pictures. Holy macaroni. You know, I was quite pleased to see that there was actual science going on and some really cool science going on. But I still think we would have been further had it not been the fact that we've been held back.
Would you agree with that, Nick?
I think the legacy of what I call the first space age is very mixed. Personally, as a space enthusiast and someone who has always been fascinated by space exploration, from seeing the first moon landings on a black and white television in my family's living room, yeah, I'm disappointed. I don't know if you've seen the film. There's a film called Orphans of Apollo that talks about the generation of people who grew up seeing the Apollo moon missions and then no follow-up. Of course, NASA would have been very happy to follow up on it, but the Nixon administration put the brakes on it. But it put the brakes on it for, primarily people viewed the space race as something, okay, we went to the moon, we proved we were better than the Russians. We don't need to do that again. And that's an unfortunate way of looking at it, but it was a consequence of the early space exploration was really a product of the Cold War. We would never have gone as far and as fast as we did. We would not have gotten to the moon in 1969 if it had not been for the Cold War, in the same way that the Second World War was so productive of technologies like ballistic missiles, radar, electronic computers, jet engines, all these things that mostly didn't exist before the war. Within 4 or 5 years, they were developed. They came into because of the national competition, and that's what Apollo is a relic of, that national competition. So apart from that,
yeah, it's a shame when you think about it. None of us like war. But when you're right, sometimes war actually pushes technology. And in fact, it always pushes technology. It's a shame that it pushes technology towards the, unfortunate side of weaponry and things like that. And but if there was a way to have, like you said, this competition, peaceful competition, it would be. I don't know if it would be as productive or not, but it would be nice for a change. Instead of having the war machine push our technology, it would be nice to have friendly technology sharing and things like that.
One could posit that the ability of human beings to come to some sort of non-military competition will be the deciding factor in the viability of our civilization. But the other thing I wanted to say about the legacy of the early space age is once NASA's budget was cut and they could no longer sustain the ambitious program of building more Saturn V rockets that they had on the drawing board at the time, they put the money into robotic probes, and really our whole idea of the universe has been transformed by the incredible science that it has done, even while the manned space program, or excuse me, even while the crewed space program or the human space program has stagnated and little has been accomplished beyond the International Space Station. The satellite, the Voyager space program, the Pioneer probes, the Viking lander on Mars, and especially the Hubble Space Telescope, and presumably, hopefully soon, the James Webb Space Telescope. You know, if you compare our knowledge of cosmology in 1969 to our knowledge of cosmology today, there's virtually no comparison. The what we know now in terms of the large scale structure of space-time and of the universe, we have dramatically increased our knowledge of the universe, and that will, as a scientific civilization, that will serve us well in the long term, and it is the necessary basis for going farther in the future, hopefully.
Yeah, we live in a golden age of astronomy, for sure, and that golden age has been driven by the space telescopes.
Yeah, I can't wait for that James Webb to get up there. But you're right about the robotics. You can't argue that. It's just, and you shouldn't really expect, like I said, to send people as far as anything beyond Mars right now. Even Mars right now is questionable. Certainly, robotics has a lot to do with it, but still, I think the technologies would have been better if it wasn't for the pushback. The war on science.
I think it's fair to say that the science that has been done is excellent.
Yes, the science has been done has been transformative, and not just the. Think of the satellites that gave the first map of the uneven cosmic microwave background radiation. That has been extremely important to cosmology, no less so than the incredible photographs of Hubble and then the specialized instruments that have given us infrared astronomy and other X-ray specialty telescopes and that sort of thing.
It's funny you should mention Hubble, because I was around when I hung around people, and my friends and my co-workers at the time were all like, yeah, they're those kind of people that say, if you can't eat it, what good is it, kind of thing, And then as soon as they had the trouble where they had to rescue it and fix it, they were like, talking, we're spending millions up there. That's that kind of rhetoric talk. And here, they gave it the glasses, so to speak. I used to joke that they gave Hubble a set of glasses, and it turned out to be the best thing we've ever done. And that.
Certainly, yeah.
It's, so far, as far as the first big space telescope, obviously there's a lot more up there now, and hopefully the James Webb will actually supersede that. But nevertheless, if it wasn't for the Hubble, like Nick said, we would not know as much. And the WMAP, of course, to find out that it was the cosmic background radiation was actually uneven. This is all wonderful, but I still go back to, we could have had more. Our technology would have been greater. There's an old joke on one of the cartoons, Family Guy. Is it Family Guy? I forget which one it is. They went back in time, changed something, and they stopped religion, and they came back into the present, and it was like the Jetsons. It was like a big joke.
So let's carry on with our trip around the solar system, and we go outwards, and we've got the asteroid belt. NASA are planning a near-Earth asteroid redirect mission sometime in the next 10 years, I think. They're going to use that mission to test their technology that's going to get them to Mars. What do you think about this idea of NASA's asteroid redirect mission as a stepping stone?
I see it as a logical extension of what's been done because, as you pointed out earlier, there are already private companies that are talking about asteroid mining. We know that there are an enormous amount of resources out there, enough so that it could change the economy of the planet. And I find it fascinating how few people talk about what would happen to the commodities market if somebody managed to land a asteroid that was packed with gold or titanium or some difficult to obtain mineral on Earth. And suddenly you go from a situation of scarcity where a metal can be a substitute for a currency to where it's as common as seawater. And that would have a very big impact on people who trade these commodities.
Yeah, right. That's an interesting thought. But yeah, I agree. It's an obvious and perfectly logical stepping stone. I mean, just like any other space exploration we've done, you start off by first learning how to orbit Earth, and then from there we went to the moon. Stepping stones. Now, if we're going to talk about asteroid mining and things like that, we first have to learn how to do that. We first have to learn how to land on them, and the Europeans obviously had done that on a comet, which was a very tricky thing to do. And redirection. We want to save the Earth from some impending asteroid that might crash here. That would be a great, not only saving the Earth and civilization, but it would be learning how to do that in order to, for example, mining might not just be going to the asteroid. It might be, well, let's redirect it to some place where we can work on it, so to speak, and that might take a couple of robots with whatever propulsion that they decide to use to bring it to somewhere near the moon, maybe where we can reach it, that sort of thing. We can't send people out all the way out to the asteroid belt and expect, to be safety reasons, and not to mention the money it would cost. And would it be financially viable to spend the money to get these people out there and to keep them surviving? And trying to mine this asteroid, would the product be worthwhile? In other words, but if you were to send, for the lack of better words, robots out there to bring it back for us, and then put it someplace where we could reach a lot easier, I think that would be a viable solution. And
yeah, the Planetary Society have also announced their suggestions on how to get to Mars just in the past week or so. They're suggesting that what NASA should do is orbit Mars first and possibly send a manned mission to one of the Martian moons. Have you read anything about that recently?
I did hear about that, and didn't a private space company already a couple of years ago suggest sending a trip that would just orbit the Mars and come back again without attempting to land?
Well, the Planetary Society wrote a whole report on it. In fact, I downloaded it. I didn't quite read the thing yet, but I read to skim through it. But yeah, there's a whole report about the idea of orbit first.
Yeah, I think the idea of landing on Phobos or Deimos is interesting, and then setting up a base there and using teleoperated rovers on the surface of Mars. That sounds like a good idea. I'm not sure I would be happy. I'm not sure I would be happy as an astronaut to spend 8 or 9 months going to Mars and then just whizzing around the planet and spending another 8 or 9 months coming back again, though.
Well, you'd still be the first one to set foot on Phobos or Deimos, so that would be something.
I landed on a potato.
Yeah. Is there even enough gravity on those small Martian moons to serve as a base, as it were?
Apparently so. I would imagine that landing would be extremely challenging. But
again, that's about the same idea as what you were saying about the idea of redirection. It's the idea is to try, to step in one direction first. First test the technology. First test, go to Phobos, for example, like you said. This redirection of the asteroids is the same idea. In other words, you don't just grab a bunch of people and just go there and find out that you shouldn't have done that.
Right. Well,
Yeah.
there's something to be said for practice makes perfect in the space exploration as well. To return to the theme of mining the asteroids, I don't think there's any question that with the contemporary space infrastructure that we have today that's primarily based on satellites and robotic missions, that the first thing we can expect to see is some kind of robotic redirection or sample return mission, and it's going to be a long time before we see the a kind of human exploration of the solar system that would require a different kind of extraterrestrial infrastructure. That is to say, habitations in Earth orbit, which could be serve as places where people could depart and return if they were going to the asteroid belt. But that being said, in addition to the influence of the Apollo missions on people our age who saw it all unfold, another great influence on me was Gerard K. O'Neill's book Colonies in Space, which contained a fictionalized account of early human settlers setting out in their tiny spacecraft to go to the asteroid belt to stake their claim on a big rock that they could mine and bring back, which held a great fascination for me. I read it many times when I was a child.
Well, I mean, since you mentioned sci-fi books that they're closely related. The books that were prior to the Ender's Game movie, the Ender's Game with the first Formic Wars, the first three books really, Orson Scott Card. It was about families out. They were called free miners, and then there was the big corporation miners, and it was a family of free miners. They were Italians that were out in the asteroid belt. That spotted the alien ship coming towards our solar system, and the one guy came into he rode in on a vehicle that was supposed to only bring back mined ore and stuff, and he modified it to put himself in there and come back to Luna, and so I mean it's. And they approached the idea that you can't travel the speed of light and everything, and this alien ship was only near speed of light and all that stuff, and there was a big war afterwards and all that stuff. But the idea that there was actually families and corporations out there mining asteroids, was sci-fi no less, but it was sort of it wasn't too elaborate to the point where it wasn't believable,
Yeah, and the account I was mentioning in Gerard K. O'Neill, that Colonies in Space was intended as a blueprint document, not as a science fiction novel. It just contained a short fictionalized account, but that was for those of us who felt disappointed that the Apollo missions weren't followed up by a robust space program. Instead, we went to the robotic probes, which have yielded great science, but it hasn't put us out there in the way that many of us would have liked to see a robust human presence in the space in the solar system, not merely for the benefit of the science that can be done by human beings, but also for existential risk mitigation. If everything goes wrong on the planet, we need a backup elsewhere to make sure that everything isn't lost as a result of a stupid cosmic accident or our own stupidity.
Yeah, it's very true that if we stay on Earth, we face extinction, along with every other form of life on the planet. We're going to have to step off this rock and go elsewhere at some point in the future. It's quite logical. Stay here and we die.
Yes, at some point.
Yeah, but I also think that other explanation has everything to do with it. There's this. I'm basically yelling at this one guy who some idiot on Google Hangouts. He's one of those people that don't understand that you can't just do one or the other. You can't just stop going to Mars and let's go to Europa. You can't do that. You have to do it all. You have to, because we're learning how to do this. We're learning how to travel there and how to land things. And with the next that we want to go to Europa. I'd like to see all kinds of things going to Europa, and not to mention Enceladus. But I think we need to do all that. I think we need to send these robots out there and to learn how to manipulate the spacecraft to the point where you can actually land there, maybe even drill into the ice. These are learning starters. Sooner or later, these are going to be manned.
It's quite interesting that NASA has stated that future Mars missions will require a collaborative effort between not only NASA itself, but its global partners, the European Space Agency, the Japanese, the Canadians.
Right.
And I think they're quite right.
Right. And scientists, as a generally speaking, if you take the government off of their shoulders, are notorious for cooperating with each other. They almost don't care about the political ramifications. They like, the hell with the politics. We're friends. We're co-scientists. We're colleagues, and that may be the thing that brings this damn planet together. Yeah.
Well, the Europeans are collaborating with the Russians on their next venture to Mars. The ExoMars rovers are going to be a collaborative effort between the European Space Agency and Roscosmos, which is good given the current political climate, because we're certainly not friends with the Russians at the moment. There are political difficulties, but the two space agencies, as they do on the International Space Station, manage to completely, they just get on with the job, don't they? And that's great.
So, what about the other stuff that's out there? Now Juno is about to reach Jupiter, and what else do we have out there going up there?
Not a lot in the outer solar system. Juno, as you say, is going to Jupiter I think it gets there in 2016. Cassini is still doing an excellent job at Saturn. What Cassini's accomplished orbiting Saturn has been amazing. It's found water plumes spouting from the south pole of Enceladus. We've learnt an awful lot about Saturn and its moons. Titan, the Huygens probe was quite successful. I mean, I think that was back in 2009, a few years ago now.
I got pictures. I made some people on the internet with those pictures. The surface of Titan. Oh man.
Yeah. And then, of course, we've just had the New Horizons flyby of Pluto, which was a spectacular success. I'm amazed at how well that actually went. I mean, they're lucky that Pluto is such a geologically diverse, amazing-looking dwarf planet.
Yeah, that was just like a payoff, unexpected payoff, that it looked so much like a planet and not just a barren rock out in space.
Yeah, that definitely was. That made the whole trip and the nerve-wracking wait well worthwhile. I mean, to find mountains made of solid ice. I mean that's just insanity.
Yeah, and because of the the distances, we're still awaiting most of the images and the science data. They're going to come back over the next year, so there's a lot more.
Yeah, we're on dial-up when it comes to the downlink, right?
Yeah, and of course, New Horizons is also going to visit a distant Kuiper Belt object. It won't get there till 2019, I think.
Oh, it's going to be that long. I thought it was going to be sooner. Wow.
No, it's a long, long way away. Yeah, New Year's Day 2019.
I thought it was something they saw close up, or relatively speaking, close up. I thought it was. I didn't know it was that far away.
It's a huge distance away.
Does anyone know if the trajectory of New Horizons is going to keep it in forever within the solar system? I assume it doesn't. Hasn't had any gravitational slingshot that's going to throw it out like Voyager.
Yeah, it's going to exit the solar system. Yeah.
Oh, it will. It's going fast enough.
Yeah, it's going fast enough.
It's the fastest man-made object ever, faster than the Voyager.
Yeah, it's actually faster than Voyager. I mean, look how long it took Voyager to even just reach Neptune and stuff. I mean, you know, we had the what do you call it? New Horizons, just on the propulsion alone, went 250,000 miles, the distance of the moon, in a matter of, what was it? A matter of hours or a few days? No, it was a matter of hours instead of the days that it took, for the Apollos to do it.
I think it started out the moon in about 6 hours.
Yeah, it started out fast, and I think it did a couple of slingshots.
Yeah, it did a gravitational assist flyby of Jupiter.
Yeah, I mean, it reached, if you think about it, it reached Pluto, I don't know the exact timing, but we're talking 9 years, where, how long did it take? I think it was more than 9 years just to reach either Jupiter or Saturn for one of the Voyagers. I mean, it was,
Yeah.
And they were lined up.
Well, if we carry on going out of the solar system, Voyager 2 is the only thing that has supplied us with decent images of Neptune and its moons and Uranus and the Uranian moons. It showed us pictures of... Go on, Nick.
I was just going to say it'll be great to have another probe all the way out going through the heliopause and exiting the solar system, and we can get more data on that and get a yet better picture of our solar system.
It certainly will, yes.
Yeah, and when you think about it, it took, 40-something years for one of the Voyagers to go as far as it is? New Horizons is going to do it in, another decade?
Yeah, it's got enough power. It's got a plutonium radioactive power cell that's going to last into the 2030s. So we should get some decent data on, the heliopause. And hopefully, if it gets there in time, interstellar space.
And the nuclear power sources they use will probably last longer than they predicted. The Voyager nuclear generator is still operating, and I was reading about that the other day, and I think it's about half or less, but it's still putting out a significant amount of electricity to be able to keep the science systems running on board. So if these devices are properly designed and made with in the way that apparently NASA did a great job of putting together the Voyager probes, they way outlast their lifetime.
That's right.
I'm sorry. On top of that, look at the technology change, the types of instrumentation that's on New Horizons. Although New Horizons is tiny, I think it's a lot smaller than Voyager. The new technology and the computer alone is going to give us data that we didn't even dream of getting, on the Voyagers.
So let me ask you guys. Let's say you sent an email, you receive an email in the morning, and you've been named principal investigator of a new solar system exploration mission. You've given us a rocket to get you there and a spacecraft that you can equip with whatever instruments you like. Where are you going to send it? Where's Pac-Man 1 going then, Patrick?
There's so much to choose from. I mean, certainly anywhere where we've discovered oceans of water is going to be one of my first thoughts. Titan is also on the list. It's hard for me to say.
You can only choose one.
I know. Do I have a couple months to think about this?
Okay. How about the Nielsen Explorer? Where are we going to send the Nielsen Explorer?
Unambiguously, the same thing Pat said, a subsurface ocean on one of the outer moons around the Jovian gas giants, whatever turn, depending on the budget available. I would prefer to have something that melts through the ice and sends a probe down into Europa or Enceladus.
Ooh,
but
that's going to be difficult.
If that were not difficult, people, you were just mentioning earlier that there are plumes that come out through cracks in the ice, and people have already speculated that a probe could be sent to orbit one of these moons and just collect what's either thrown up on the surface or plumed out into space. But certainly my priority would be the one of these moons with a subsurface liquid ocean kept warm by gravitational tidal forces, where is probably our best bet for finding an independent origin for life within our own solar system. As Carl Sagan once said, and as I've quoted before, our first evidence of any extraterrestrial life is going to deprovincialize biology, and it will be really exciting for anyone. Hopefully, I would think anybody would be interested, but particularly biologists, to see how closely the structure of life or originating elsewhere resembles the structure of life on Earth. So, yeah, that would be my priority. Probably Europa, but whatever turned out to be the most cost-effective mission to get the most scientific data on a subsurface Jovian moon ocean.
Yeah, Patrick, you have an answer?
Yeah, I mean, like I was saying, jokingly I said, "Do I have a couple months to think about it because there's so many?" But absolutely, the subsurface oceans are the most enticing. And now that we're finding oceans on more than just the Jovian moons, we're finding supposedly the Saturnian moons as well. I mean, I'd pick one, maybe one that's easier to get to, but certainly to delve in, to dive into the ocean.
I would imagine
stick our head under there and see a whale swimming around. That would be cool.
Yeah, Europa's probably easier to get to than Enceladus.
Yeah, that's true.
NASA are planning a Europa Clipper mission sometime around 2030, I think, but these things tend to get put back, so it's hard to say when it will go.
A rover that could be landed on the surface of one of these ice-covered moons and could scrape up potential biological samples would be a great compromise between an orbital probe just sampling the geysers that get shot up and something actually melting through the ice and going into the ocean. But if we could get sample missions for two or more potential subsurface oceans, that would be even better, because that would be the potential, not the guarantee, but so the potential of finding two independent origins of life in our solar system distinct from the Earth. And that would be fantastic for biology.
I would like to see some kind of return mission, because as of right now, even though they have and don't get me wrong, I don't really know exactly how the technology works, but I understand that no matter how good the rover and the instruments are designed, to actually look at this thing and say, yes, this is alive, it takes more than a microscope. It takes more than a computer to tell you this. You have to have an eyeball, a human eyeball, to say, yes, this is alive. I would like to see something taken back, like they're going to supposedly planning from Mars. They're talk about taking some samples, leaving samples on the surface of Mars, and then sending a later mission to bring them back. I would like to see something like that, because there's no way we're going to send humans up to Enceladus or Europa anytime soon. But I would like to see some sort of return, and that would be the geyser idea of driving through it and collecting some of the stuff coming out of the geyser, so that you don't have to land and then lift off again. That would be more, what's the word I'm looking for, reasonable to expect a space mission, out of a space mission, to be able to go there, swing around, fly through the geyser and then come back with some of the material. That would probably be more feasible, I think, the word I'm looking for, in a shorter term. Perhaps further future, another 5 or 10 years after that, maybe there's a lander involved. But I think the easier one would be the better one at the moment.
I think the problem at the moment is we have no idea how thick the ice crust of Europa or Enceladus is.
Yeah, well, the same ship could have radar on it. In fact, I think they already chose them. One of the instruments was supposed to be a radar, to try to with radar to try to go through the ice. And if they come back with data saying that it's thicker than the radar can reach, then they know it's thicker. If it comes back with penetrating the ice and seeing that there's an ocean on there, then they know it's not that thick. So there is ideas for that.
Yeah.
And it was, in fact, it was an argument. I think, from correct me if I'm wrong or if I'm overstating it, but there was sort of a disagreement or an argument because it's obviously a high power instrument or device, because we're talking radar here. You're talking about a transmitter of radio waves, so you're talking about using high power. And they're sending this thing with solar cells. So there was a question as to whether or not it was feasible to send a ship up with solar cells and have a power unit on it that uses a lot of power,
Yeah. I think if I were given the opportunity, I would send an orbiter to Uranus, because like Venus, it really hasn't received the attention it deserves. Uranus is a very strange world. It orbits on its side, and it has a number of moons that we know very little about. There's Ariel, Oberon, Miranda. There are 5 or 6 moons orbiting Uranus that we've got 2 or 3 images from Voyager 2, and that's it. So I really would like to learn more about Uranus.
Well, in light of what the Kepler mission has shown us about how common super-Earths are, Uranus and Neptune would both be very interesting in light of similar planetary systems elsewhere, of renewed interest in view of that fact, perhaps.
Yeah. We're still making strides to understand the solar system, aren't we?
Yes, we are.
The study of exoplanets has certainly helped.
I admit I haven't. I admit that I have forgotten about Uranus. Poor little Uranus. I forgot about that one. Yeah, that would be logical to say, because, like you said, we haven't much about Uranus, except for what we got from Voyager. It would be logical to say, well, let's go there with another probe and see what else we can find out.
Yeah, I think it's fair to say that if we were in charge of the world's space exploration activities, we'd be off here, there, and everywhere.
To return to the idea of a sample return mission, I think that's a great idea, but a question. Don't you think that within the next 10 years, and certainly within the next 20 years, that we could design a science package that could analyze the biochemistry of a sample taken either from a geyser or from the surface of an ice-covered moon?
If you're asking me, I would say I would love to see that. In fact, I'm wondering if we couldn't have had that already if we hadn't been held back. That's one of those holdback things that I'm thinking about,
But in terms of the science available right now, it doesn't seem impossibly distant to we can't really speak of DNA sequencing because we don't know that other life is going to have DNA, or how closely the biochemistry will resemble DNA and life on Earth. But it doesn't seem like an impossible task to me to design such a science package, although it would be great to return the sample.
I'm sorry. I was watching one of the news conferences about like the water on Mars and stuff like that, and one of the two conferences, one of the scientists, and forgive me for not remembering who it was, whether it was a he or she. They were asked a very similar question about looking for life, and he or she were saying, well, a couple of times I've heard this mentioned by all the Mars scientists, the idea that it's difficult. It's easy to look for organic compounds, but we haven't really got the technology down to the point where we can put this into a robot sensor of some kind and say, is this alive? And there's no way for it to actually say yes, it is, or no, it isn't. All we can do is say it has these compounds, it has these. And I'm not sure I understand why that is. And I could understand the difference of having an eyeball on it, human, brain looking at it. But apparently, we're still several years, if not a dozen years away from creating an instrument that can literally look for life. Other than looking at a macro-sized creature crawling around, other than that, I just don't know. I think we'll have to talk to some of those NASA scientists, biologists.
Well, it's not just a biological problem, it's also a philosophical problem, because you have to ask how different can biochemistry be and still qualify as something that we would recognize as life. Could we recognize life that's almost identical to terrestrial life? It seems pretty likely, but the further it departs from that, the more it becomes a question of definition. And there's no universally accepted definition of life, and there's more importantly, there's no definite line in the sand that divides biochemistry from the rest of chemistry. There's people speculate.
No, actually, there is. I mean, we know what a cell looks like. All right, I understand about the departures from what we know as life, but if we stick to what we do know, and of all the things we've studied here on Earth, and of all the strange things we see here on Earth, we still see cells, and we know what a cell looks like. Even in a plant cell, it looks the same. We know what that looks like, and things like that. So there are, we can look for. I mean, if we were able to put a literal optical microscope on one of these instruments and be able to transmit a high-definition image, and we've got high-definition cameras, why not, right? Of a magnified sample and look for a cell, a fossilized cell on Mars, for example, or when we go to Europa or Enceladus, whichever one has those plumes, and put that under a microscope and literally put our transmitted radio signal eyeball on this microscope and say, look, it's squiggling, or look, there's a cell there, or that looks like, I mean, that would be a big difference. Now, when you depart from what life as we know it, that can go into all kinds of, woo-shoo stuff, but nevertheless, I think we can recognize life at least as we know it, and even maybe life as we don't know it. I mean, I think there's still similarities, especially since you were talking about our solar system likely has the same stuff, and it may be more on one planet than the other. Like, for example, I hate to keep talking about Mars, but we know now that Mars has a lot of these prochlorates or perchlorates, however you pronounce that word, and it's poisonous to us. It's like a big Superfund site, the entire planet. But this because of the dry up of the moisture that was there. So, in other words, there's a lot of the same stuff there. Even when you look at the dried up lake beds and the sedimentary rock and stuff, you can. I mean, it doesn't take a leap of an imagination, and it doesn't take a scientist to look at these two pictures, one from Earth and one from Mars, and say, yeah, this looks the same. This looks like there was a river flowing through this, or there was a lake on this, and just to have that familiarity, it's just, to look for life as we know it would not be a far stretch to ask to look for life as we know it on Mars, even if it's fossilized life, even if it's not there no more, it would not be a far stretch.
No, I agree.
Yeah, the difficulty is always going to be in trying to distinguish between life that's Martian in origin and life that we've taken there with us.
Yeah, that's the big thing. And there's a sterilization question. I think we had somebody on the Unseen podcast. We had that woman, what's her name? She was the driller on the Mars rover, the Curiosity. I forgot her name. Pardon me for forgetting her name.
It's escaped me as well.
Yeah, it's on the tip of my tongue, but we'll go back and find it. But I was in that Unseen podcast, and I found her information to be. Oh, I wasn't in it. I was watching it from the outside. And
it cost about $100 million to sterilize one of the rovers, and that in essence is why Curiosity didn't get sterilized. It would have added $100 million to the price tag.
I didn't know that Curiosity was not sterilized.
No, it wasn't.
I thought it was, at least to an extent. Maybe not as much as they would wanted it to.
No, the Viking landers were the only ones that have undergone a pretty thorough sterilization procedure, because they did have experiments on them looking for life. Curiosity is kind of banned from going to regions of Mars that scientists consider may have life in them.
Oh, right,
so
right. Yeah, I heard that.
It wasn't sterilized.
It's like it can look at the this water flowing at a distance, but it's not allowed to go there and put the drill in it. But in the thing.
That's right.
Funny. That's strange to me,
Well, it's simply because it hasn't been sterilized.
Yeah. Screw the Martians. Let's go there anyway. If we contaminate them, that's too bad for them.
Well, arguably, we have already contaminated them by sending several probes to the surface that are not absolutely sterilized.
Yeah. The Soviets crashed into Mars back in the 60s with a spacecraft that underwent no kind of sterilization whatsoever.
Yeah, I doubt if they're worried about it like we are. At least we're thinking about it, even if we don't do it.
Well, planetary protection's a lot bigger issue now than it has been in the past. You're muted, Nick.
Yeah, it's become quite a prominent issue. I happened to click on a live NASA broadcast, yesterday or the day before, when they were talking about the structures on Ceres, and there was an audience question explicitly asking about this, and planetary protection has been. In fact, there was an editorial in the Financial Times this past week of somebody writing about the need for planetary protection and not contaminating Mars, as it were. And I hope this doesn't become another excuse, not to do anything and to prevent the exploration of the solar system. I think that would be very sad indeed. We need to take basic measures to not do anything disastrous, but it shouldn't be allowed to be an excuse that we're just going to hunker down here on Earth and do nothing, because if we leave the planet, we might destroy some microbes on Mars.
Well, we do carry a few million microbes around with us in our bodies, don't we?
An enormous number, yes.
Yeah, I don't think there are any plans for anyone to get naked.
Well, when you think about it, yeah, that's true too. But when you think about it, the Mars One people that we just recently talked to, their plan is to go there and colonize. So, I mean, there's just no getting around it. You can't sterilize yourself, except your skin maybe. But there's going to be, it's going to happen.
It wouldn't be advisable to lose all of the microbes in your stomach, would it?
Well, if
have you seen The Martian?
Yes, that's a plot point of the film.
Yeah, he was using his own shit to grow food.
But that's a readily available source of nutritious microorganisms. So, if it was that or die, one could understand.
Right. I mean, we're talking about sterilizing and contamination. Well, forget about all that.
Yeah, well, that's why it's a done deal. If human beings go somewhere and actually settle there, they've contaminated it simply by their presence. If they're long enough to leave wastes or to engage in any form of food production,
the minute you talk about landing there, you're talking about contaminating. I mean, it's you can bag it, you can try anything you want, but it's not gonna be perfect. And there's. So, I mean, I'm not saying that we can't take any precautions on the robots that we send there, but I am saying that there's no getting around it sooner or later. If we're going to go there, like Mars One wants to go there sooner than NASA, if we're going to go there, it's going to happen anyway.
And if the primary belief is that if there was life on Mars, it would only be present in fossil form today. It's not going to affect the fossils of Martian life, and Martian life hasn't reached the stage of being critters scurrying around in the desert, so we're not going to be killing any macroscopic organisms by going there. So
right, but essentially, the bacteria and stuff that they say has survived, dozens of years of space exposure, and then get warmed up and suddenly come back to life, so to speak. If you think about it that way, then potentially it has the ability to change everything. The interactions between the organisms that we will bring there and the organisms that might be there. And when I say might, I think there might be, but you have a potential of change.
I think
you have a potential of changing the life that could have been there.
There's a fair chance that there is microbial life deep within the Martian soil. I mean, we don't know until we look. It was interesting that Curiosity found methane plumes.
Yeah. The methane can come from one type or another, but that's the point. The point is that there's going to be, if there is, assuming that there is, just for the sake of argument, microbial life beneath the surface and within those water, this highly salty water, anything that we bring there may interact with it and change the life there forever.
Not to mention changing our own life forever, possibly. In an earlier Unseen podcast, Paul Carr just briefly dropped the comment, but I think it's a very profound idea that because of the substantial amount of mass transfer between the inner planets, if there is life both on Mars and Earth and anywhere else within the inner solar system, it may have already been exchanged among planets, which is of course a form of panspermia confined within our solar system. But that if we find life on the outer solar system in the Europa or the other Jovian moons that may have subsurface oceans, it seems much more likely that is going to be a separate genesis, as it were.
Yeah, that is the big question. If and when we find life elsewhere, will it be related to us? We simply can't answer that question at the moment.
And that's why I said it's going to deprovincialize biology when we have that samples that we can examine.
Yeah, like I said, there's no getting around it. It's going to happen, particularly if we're sending people anywhere. Sending robots, of course, the chances are less. And the idea of sterilizing it is a good idea. And even I think it was this woman who was saying that even our best sterilization still leaves a few %. So it's never perfect. So if there is life anywhere that we send even robots to, it's it can have the potential of changing. Of course, we're talking about a minute amount. When you're talking about a planetary body, a moon or a planet, as opposed to a few microbes left on this spacecraft, chances, statistically speaking, are so slim, that anything can completely change. On the other hand, if you're a science fiction fan like myself, that slight little difference, that microbe could have just been waiting for that one microbe to come along, That's
okay. Well, I think we'd better wrap things up. So, Nick, have you got any final words, comments you'd like to add?
I'm drawing a blank at the present time, but I thank you for the opportunity to speak again on the Unseen podcast.
You're very welcome. Patrick, thank you very much.
Yeah. I'm sorry. Yeah, I'm happy that I was able to help, and I'm sorry that I couldn't do more. I'm disappointed that the other members were not able to, or did not see, or for whatever reason weren't here. But I thought we had an interesting conversation between the anyway. And being patented now. But thank you for inviting me, and I hope I can help again some other time.
You're very welcome. Okay, thank you guys, and we'll be back next week.
Thank you.
Okay, so I guess I pushed the stop broadcast.
Hit it.